we're going to find the solution of the differential equation dy dx plus x squared y equals y, given the initial value y of 0 equals 4. That's kind of funny notation. That's just like f of 0 equals 4. Okay? In other words, 0 is your x, y is your 4 in your specific solution. Okay? Here we go. This is looking separable. So I'm going to first subtract that over. I'm going to divide the y. I'm going to multiply the x, the dx. So I've separated my y's and my x's. I'm going to take the integral of both sides. Ooh! 1 over y, the antiderivative of 1 over y is the natural log of the absolute value of y. The antiderivative, or the indefinite derivative integral of negative x squared is negative 1/3 x cubed. I'm putting my plus c over there. Okay, but now I want to solve for y. So algebra isn't going to do the trick, because I have a natural log, transcendent function. Think about how you're going to isolate y here. Let's remember you have a little invisible e there. You could rewrite this in log form. Remember our b to the x equals n. That's the definition of a log, right? So I have e raised to that exponent, e raised to that whole shebang equals the absolute value of y. Very cool. Okay, now, you might think you could leave it like this, but we are going to continue, and I'm going to show you kind of the standard protocol here. Let me bring the y over on this side just because I feel like it. You know when you have exponents, like if I had x to the a plus b, well, let me do it this way. If I had x to the a times x to the b, you know that that's really x to the a plus b, right? So I'm going to go backwards, and I'm going to say this is e raised to the something plus something. So I'm going to rewrite that as e to the something times e to the other something. So if that freaked you out, just pause the video and look at it. Think about this little property. We went from this to this. I think you're going to be okay with that if you think about it long enough. Okay, so I have the absolute value of y equals this e to the negative 1/3 x cubed times e to the c. Well, e is just a constant, 2.7 blah, blah, blah. What's a constant raised to some other arbitrary constant? Some other constant. So I'm just going to say this whole thing is multiplied by some constant, some c. That's a different c than that, but some constant. And in fact, I can now get rid of the absolute values. Remember, to get rid of the absolute values, I can just put a plus or minus over here. But what does plus or minus some arbitrary constant mean? It just means, oh, it's some constant. So this would be my general solution to my initial, to my differential equation. Y equals some constant times e raised to that exponent. Okay? But I didn't ask for a general solution. I asked for a specific solution. And let's go back and see. I guess my original point was 0, 4. So when x is 0, my y is 4. So let's actually finish this problem and find the c. So my y is 4. I'm going to solve for c. My x is 0. Well, that's convenient. That gives me 4 equals c times e to the 0. E to the 0 we know is 1, so my c is 4. So my specific value here would be 4 times e to the negative 1/3 x cubed. Da da la da da!
His horse and his cattle are his only